Hi everyone. So today we'll discuss another Leetcode problem. Basically, this problem is the first Leetcode problem in that platform. So the problem is popularly known as two sum. So what we have to do, we have to return the indices whose sum is equal to the target. What does it mean? I have not read this question so far, but I will explain you what we have to find in simple way. So see the example one. So we are given a nums array where the elements are present 2, 7, 11 and 15 and the target is 9. So from these elements we have to return those indices from this array whose sum is equal to 9. So if you carefully observe, if we do the 2 plus 7, we will get our target sum. So this is our 9. So we have to return its indices. This would be 0 for 2 and 1 for 7. That's it. That is the main, very simple and simple problem. So we have to do that thing. So let's see another example for more clarification. So see this example 2. The array is given 3, 2 and 4 and our target is 6. So we have to return those indices whose sum is equal to our target. So if you see, if we do 3 plus 4 we will get 7. If we do 3 plus 2 we will get 5. But if we do 3 plus if we do 2 plus 4 we will get our sum. So we have to return the indices of 2 and 4. What is the indices of 2 and 4? If 3 is present in the 0th index, 2 is present in the first index and 4 is present in the second index. So we have to return 1 and 2 arrays. So this is our desired output. So now let's discuss about its different approaches, how we can solve this problem. So I will discuss only two approaches. First one would be our brute force approach, and another I will discuss the optimal using HashMap. And if you guys are following me from the first video, I'm more emphasizing on the HashMap data structure because HashMap data structure is very efficient and we can solve different problem using HashMap. So I would highly recommend you to take a good grip from this, take a good grip in this HashMap data structure. It's a very important and efficient data structure. So now let's see the brute force solution. So brute force is very simple. Just we have to maintain two for loops. One will be starting from our 0th index and one will be starting from 0 plus 1 index. So if we take a 0th index pointer as a I and a 0 plus 1 index pointer would be j, then it will run up to the length minus 1, means to the last element of that array. So if you are not able to map this concept, let me do the dry run. So the array is given 2, 7, 11 and 15. So first pointer I will be starting from this index, the second pointer j will be starting from this index, and it will move towards this direction. Towards this direction means it will check every elements and it will stop until we reach the last element of that array. So now when this for loops will running or iterating or traversing from this array, we have to maintain one condition, that whether if our nums.i plus nums.j equal to target sum or not. That is the main condition. So this is the main condition, whether our nums.i and nums.j are equal to target or not. So see, let me change this color. So initially the first pointer I would be in the 0th index. So what is our nums I here? 2. So second pointer will be starting from this index. So z pointer, what is the element present in the z pointer? That is 7. So now check, this is for j. So now check, doing the plus operation here, 7, 2 plus 7, what we are getting? We are getting 9. So 9 is equal to our target sum. It means we are getting, and we got our desired output. So for this example it was easy. Let's take the second example and see the brute force solution dry run. Let me remove the all. So in the second example, the array is given 3 to 4 and our target is 6. So first for loop will start it from this index I, and second for loop will start it from this index j. So it will check whether 3 plus 2 equal or equal 6 or not. No, it does not. We will get 5. So this is not our desired output, and we don't have to return the index of 3 and 2. So after that I pointer will move to this in this position, and z pointer will move to this position. So now when the moment when this I and j pointer will reach 2 and 4, this will again check the condition that whether 2 plus 4 equal 6 or not. Yes, 2 plus 4 equals 6. So we got our desired output 6. So we have to just return its indexes. So what is the index for 2? Index would be 1, and what is the index for 4? The index would be 2. So we have to return it as an array 1, 2. So that is our output. I hope this is clear for you. I'm just quickly writing the pseudo code for this solution, mean this brute force approach. So the pseudo code would be, first of all we have to take one array, let's rename it int array equal, let's create this array, new, sorry, this should not be int new, int array equal new int 2. We need the array size is 2 because we have to return only 2 index as the output is given. So after that we have to maintain 2 for loops. The first for loop will be starting from int I equal 0, it will run up to nums dot length -1, then increment, then again we have to maintain another for loop that will run up to the last, it will start from I plus 1 position and it will run up to nums j less than equal so j less than equal nums dot length then j plus plus. So after that the most important condition, if nums I plus nums j equal target or not. If it does, then return array, and if it is not, then again this loop will start and it will iterate through the whole array and keep checking this condition. So this is our brute force solution. I hope you understood this brute force solution. Now we'll move to the optimal solution. Why? Because if you observe carefully here, the time complexity for the brute force solution is order of n square, and the space complexity would be order of 1. Alright, so far we have seen the brute force approach, and the brute force approach we are getting the time complexity is order of n square and the space complexity is order of 1. So interviewer might not happy with this approach, so he or she will ask you to optimize the code. So how can we optimize the code? We'll be using here, that's our second approach, using HashMap. So let's see how HashMap will work. So initially we have to create one empty HashMap, and our element in the array, whatever the element is given, 2, 7, 11 and 15, and target is 9. So the we have to maintain one for loop to traverse this array. It's simple. So go to the first element and check whether this element is present in the hash map or not. No, it does not present. So now put this element with its index 2 and 0, and 2 and 0 would be the key and value for this 2 element. So now once we store this 2 and 0 here, we have to do one thing here. We have to minus the current element from this target. So if we do 9 minus 2, what we will get? We will get 7 here. So now if you carefully observe here, the 2 plus 7 is giving us 9. That's why we have to return this 7 and 2. How can we return this 7 and 2? We'll maintaining one result array which size would be 2, and we'll just return in the result first index would be our current element. The current element is 2 here, and the result arrays 0th index would be our the target minus nums I element. So target minus nums I element means this element, this element, this 7. So 7. Just we have to return this 2 and 7 as an array. So if we are guys not able to map this concept, let me go through the second example, and that will make you clear the thing, because this example we are getting from getting the answer from the 0th and first index. So now let's see the second example. 3 to 4 is given in the array and the target is 6. So let's check, is there any element present in the hash map? No. So we have to put the 3 and its index here, and after putting this 3 and 0 here, we have to do the 6 minus 3 equal 3. So now check whether the 2 is present in the hash map or not. No, it does not present in the hash map. So let's put this 2 and its index here. So again do 6 minus 2 equal 4. Now let's, before moving to this 4, here if you observe carefully, what we are getting here 2, what we are getting here 4. If you do 4 plus 2, what we will be getting here 6. What is the 6? 6 is our target. So we got our desired output here. I hope it's clear for you. So that's it for this approach. So let's quickly discuss about its time and space complexity. So the time complexity for this approach would be time Okay, so time complexity of this approach should be order of n. Why order of n? As every element is visited at most 2 times and HashMap operations take constant time. So that's why the time complexity will be order of n here. And what is the space complexity? The space complexity will be order of n, as the every element is stored in the HashMap. So it will take order of n space. So far we have seen the approach brute force, and the optimal approach is HashMap. So I have discussed the brute force approach pseudocode in the theory section. Now let's see the code for the HashMap part. So what we have done, we have taken input as the input nums array and the target. We have created this result array to store this 0 and 1 index, and after that we have created this HashMap. We have traversed over every element using this for loop, and we are checking whether hash.contains key equal target minus nums I or not. If it does, then we will store the result 1 equal the current element, and the result 0 will be the hash.get is equal target minus nums I. And lastly, what we will do, we'll just simply return the result. So I hope the code and the concept is clear for you. Just in case if you get any difficulty to understand this concept or any problem in the code, feel free to ask me in the comment section. So that's all for today. Let's meet in a new video. All right, bye then.